Hello everyone and welcome to Kiru's online lectures. I am Kira Jamtani and today's topic is Haloalkanes and Haloarenes part 2. In part 1 we already discussed about the introduction, reactions in organic chemistry, nucleophilic substitution and elimination reaction mechanism. Now in part 2 we are going to study substitution and elimination reaction and stereochemistry. Now coming on to substitution and elimination reaction. So any species that act as a base can also act as a nucleophile. So to understand how elimination and substitution compete with each other, we compare nucleophile behavior with the basic behavior. So coming on to nucleophilicity versus basicity. The nucleophilicity and basicity will be parallel if the comparing nucleophile have same attacking atom. Example like we have example CH3O minus is nucleophile is greater attacking agent, that is it is more basic as compared to OH minus as compared to CH3COO minus. Negatively charged nucleophiles, they are stronger than neutral electrophiles. So negatively charged electrophiles like OH minus is stronger than H2O, or we can say NH2 minus is stronger than NH3. Electrons on larger atom are less tightly bound by nucleus and are more polarizable and most readily available to the carbon will be better nucleophile. But yes, they will be weaker base as their bond with smaller hydrogen atom will be weaker base and their acids will be more reactive. So if we compare their acidic sequence, so HF is more acidic than H2O, then NH3 and then it is CH4. So once we understand this nucleophile and basicity character, then we can understand how substitution reactions compete with the elimination reactions. Basic strength and nucleophilicity. If we talk about basic strength, so F minus is more basic as compared to OH minus, as compared to NH2 minus, as compared to CH3 minus. Now if attacking atoms are different in size, so then nucleophilicity depends on the solvents. However, in gaseous phase, nucleophilicity parallels basicity. Then nucleophilicity is inversely proportional to the stability of the ion, like we have RCOO minus, it is weaker nucleophile as it is resonance stabilized. Then steric factor, it limits nucleophilicity, as we can see over here CH3CH2O minus, it is more nucleophile as compared to CH3 whole thrice CO minus. So this since over here it is tertiary carbon, more is the steric effect, so lesser is the nucleophilicity. But yes, when we talk about its basicity, so the sequence for basicity it reverses. CH3 whole thrice CO minus is more basic than CH3 CH2O minus. Stronger base can be made a good leaving agent, like oxygen containing group like OH. It can be made a weak base in acidic medium by protonation and they become a better leaving agent, that is OH2 plus. Similarly, protic solvents, so these solvents which have hydrogen atom attached to an atom of strong electronegative element like oxygen, so that is known as protic solvents. Then when we talk about more molecules of protic solvent can therefore they form hydrogen bonds to the nucleophile. So hence when we talk about protic solvents, nucleophilicity is reverse of basicity, that is F minus, Cl minus, Br minus, I minus. This is increasing basicity sequence. but if we talk about from here to here, it is increasing nucleophilicity center sequence. Aprotic solvents, so these are the polar solvents that don't have H atom, hydrogen atom they are not having, like we have NN dimethyl formide, dimethyl sulfoxide, these all are not having hydrogen atoms, they are capable of forming hydrogen bonds, therefore we call it as aprotic solvents. Now coming on to stereochemistry. Now stereochemistry, when we talk about stereochemistry, in that we talk about regioselectivity. It is basically the preference of one direction of chemical bond making or breaking over all other possible directions. Like we have over here alkyl halide, which is 2-bromobutane. Now if it reacts with alcoholic KOH, we know alcoholic KOH, it participates in dehydrohalogenation. So here we will remove H from this carbon because Sedgwick rule will be followed, which states hydrogen is removed from the carbon having less number of hydrogen. So the major product formed over here will be CH3, CH, double bond CH, CH3. So this is only regioselectivity, which basically it is basically the preference of one direction of chemical bond making or breaking over all other possible directions. Coming on to stereoselectivity. Stereoselectivity means the reaction that gives one predominant product because the reaction pathway has a choice. Either the pathway of lower activation energy is preferred or the most stable product is preferred. For example, we have product like this. Here it is phenyl group attached to it, then OH group. So when we heat it in presence of H plus, this OH and obviously water will be removed. So there will be two products formed over here. So one product will dominate over the other. So this is the major product which is formed over here. So this is how this condition is known as stereoselectivity, in which pathway of lower kinetic energy is preferred or the most stable pathway is preferred. Coming on to stereospecificity. So stereospecific reactions, they basically lead to the production of single isomer as a direct relation of mechanism of the reaction and the stereochemistry of the starting material. There is no choice. The reaction gives a different diastereomers of the product from each stereoisomer of the starting material. Like over here, only one isomer can be formed, like trans or cis isomer, which we have already studied when we were talking about the preparation of alkenes from alkynes. So the conditions are given over there. If we take palletized charcoal, we will get cis isomer. If we are taking sodium in liquid ammonia, we will get trans isomer. So this is known as stereospecificity. Now chemoselectivity is basically when there are two or more functional groups in a molecule. A given reagent may react preferentially with one rather than the other. Therefore, it is known as chemoselectivity. So, in today's video, we studied about substitution and elimination reaction, and we also studied about stereochemistry. Hope you guys are finding videos helpful. So, do like, share and subscribe the channel. Thank you.